Hey everybody. So I haven't been making a lot of videos recently. I've been deep into the throes of writing the new version of the Nature of Code book, and I am pleased to report that I am making progress. At the end of this video, maybe I'll circle back to that and let you know more about what you can find. But this wonderful thing happened. I was busy rewriting chapter 6, a chapter about rigid body and soft body physics with different kinds of libraries, matter.js and ToxicLibs.js. And I saw this tweet, it was a month ago, from Juhani Halkomaki, this incredible, beautiful world of blobs all colliding with each other. And I just thought to myself, this reminds me of a project that really got me inspired to write the original Nature of Code back in 2008, called Nokia Friends. This was a project by Carsten Schmidt with a bunch of cute, cuddly little squishy characters that bounced around. Now that project was built with a library called ToxicLibs. ToxicLibs started, I think, around 2005, a sweeping and pioneering open source library for computational design. It wasn't just one little library, it had multiple packages: geometry, 3D, 2D, audio, color utilities, physics, so many more things. And it was available for processing, which was the environment I was learning and using the most at the time. Now that library is no longer maintained, and you should really check out what Carsten Schmidt is currently working on at thi.ng. I'll put links all over the screen and in the video description. But I just can't stop using ToxicLibs. It has a special place in my heart. It's critical to the history of computational design and generative art. And there is a wonderful port of it from Kyle Phillips, Haptic Data Online, into JavaScript. So ToxicLibs.javascript is still on the internet today. It works. It's supported. I am excited to use it. So I want to make my own squishy, cute, soft body character as a coding challenge in this video using ToxicLibs.js. Before I dig into the code, let me tell you about some really important references that you might want to dig into if you want to know all there is to know about soft body physics. So the seminal paper in my mind is called Advanced Character Physics. It was published in 2001 by Thomas Jakobsen as part of the Game Developers Conference. And Jakobsen was working for IO Interactive, a game design company, and developed these algorithms and this methodology for the game Hitman, codename 47. And the implementation of what's called verlet physics in the ToxicLibs library would match exactly what's in this paper. You might have also heard of a game called Jellycar, and there's a recent wonderful YouTube explainer that goes through everything about how the soft body physics in that game was implemented and how it all works. Now, in this video, I'm going to be using ToxicLibs as the physics library, but there are plenty of other physics libraries that you could consider doing something similar with. Two that I would mention that I've made videos about before, quite old videos, Box2D, and maybe a little bit more recently, matter.js. So I will include links to all of that material in this video's description as well. All physics libraries tend to come with some number of elements that define the world and the things in that world. In ToxicLibs, in the ToxicLibs of verlet physics, there are 3, 4, or maybe 5 things that I want to talk about. The first element that's critical for the physics simulation is the world itself. And you can think of the world as the P5 canvas. Then there is the concept of a particle, a single point in that world. Now, I'll probably choose to draw the particle as a circle, but in the actual physics itself, it is considered to be a single point mass. It does not have any geometry. This is a pure soft body world that we can build geometry in out of particles, but if you're interested in rigid body physics, that's where you want to go back and look at some of these other examples of physics libraries. If you have two particles, particle 1 and particle 2, they can be connected with a spring. Other terms for this might be joint or constraint. The idea is that there is some relationship between these two particles governed by a force that obeys Hooke's law, springs. And if you want to learn more about how to implement your own spring force, hey, guess what? I have a coding challenge video all about that for you to watch. A behavior is the idea of a force that can be added to either the world or to an individual particle. So there's such thing as a gravity behavior. If I put that in the world, then all the particles experience gravity. There's an attraction behavior that I could add to an individual particle, and then all the other particles are attracted to it. Make it negative, it's a repulsion force. Lots of possibilities there. We'll get into that as I start coding. I should also mention that there are classes in ToxicLibs for geometry. So I'm not going to be using P5 vector, which is what I typically use in most of my examples, because ToxicLibs has its own vec2d object. And there are other objects for other kinds of geometry, and I'll get into them as I need to use them. All right, let's dive in and see if we can create a sketch that has a physics world, 2 particles, and 1 spring that connects them, and maybe a gravity behavior. That I think we could do pretty quickly and easily, and then we'll move on to seeing if we can build an entire character out of particles and springs. I'll be demonstrating this with the P5 web editor. If you want to follow along, I'll link a sketch that is blank, but has the ToxicLibs library imported, as well as the P5JS library. And then, of course, I'll have a link to the end result of whatever I code in this particular video. All right, first up, I want to make a physics world. So I'm going to create a variable, call it physics. The full name for a physics world with ToxicLibs is Verlet Physics 2D. I imported the library, and yet it says Verlet Physics 2D is not defined. The ToxicLibs.js website has a Getting Started section, which will walk you through how to get going with the ToxicLibs library. The original documentation for the Java version is no longer online, but I see it as a personal mission to keep these things alive. So I have actually hosted that library, revived it at a GitHub repository that I've set up that I'll link to in the description. And what you'll see here is that the Verlet Physics 2D class is part of the package toxi.physics2d. ToxicLibs, if you remember, is a suite of many, many, many different libraries all bundled together. If I want to create a Verlet Physics world, I've got to reference the full path. But this is fairly inconvenient to have to do all throughout the code. So I'm going to use something called object destructuring to pull out the classes that I intend to use from the ToxicLibs packages. I should really make a short little quick video on object destructuring. If you want to see that, let me know in the comments. But what I'm doing is toxi.physics2d is an object with properties, and I'm pulling those properties, destructuring the object out into individual variables with the same name through this syntax. And even though I like to just use let everywhere to make things friendly and less confusing, this is probably a case where I really should declare these variables with const, because they're never going to change. Now, in addition to pulling out the Verlet Physics 2D class, I also have access to the Verlet Particle 2D. And I have made a Verlet particle at x320, y100. Let's draw that particle. And there it is, but it's not experiencing any physics yet. How about we add a gravity behavior to the world? Oh, I didn't import the gravity behavior. There we go. Now I have access to gravity behavior. Now to make a gravity behavior, I need a vector to say what direction is the gravity pointing in and how strong is it. This would be a vector pointing down. Oh, but I've got to import that vector class. The vector class is actually part of toxi.geometry rather than physics. Now I'm not seeing the gravity yet. This is a really critical thing about ToxicLibs and most physics engines. Just because you create a particle, a behavior, a spring, it doesn't automatically activate within the world unless you explicitly add it to the world. So I need to say physics, add behavior, gravity. What did I miss here? Okay, so I'm getting a weird error here. It's undefined. I made this vector, but I forgot to create the gravity with that vector, so that should go there. And there we go. Still no gravity. Now, I like to write things out in many separate steps because it makes it a bit easier to follow, especially if you're new to this. But I do want to point out that I don't have to make a separate variable for v and a separate variable for gravity. Just to prove that point, I could create the new vector right here when I make the gravity behavior, and I could do the same thing with the gravity behavior in the add behavior function, but I'll leave that to you. Still, though, no physics happening. Guess what I'm missing? I made the gravity and added it. I made the particle, but I didn't add it. Everything that I make, I have to add explicitly to the physics world. But I still see no physics. I've forgotten a critical step. And in fact, that word step is maybe a clue. If you are used to P5, you're probably used to the idea of time moving forward by the draw function looping over and over again. You've always controlled your animation and behaviors through that fact. Through the fact that you have a variable that you change and you draw something one way, then draw loops and you draw something another way, and so on and so forth. The draw loop is continuing to loop, but the physics world is not moving forward in time. It's up to us to specifically tie those two concepts together. The physics world takes a step forward in time when you call physics.update. The easiest way to have this all work then is to just have physics update happen every time through draw. There are all sorts of ways we could get more sophisticated about that, but this is going to do the job for us. And as you see, now gravity is in play. Let's add a boundary to the world. I need that rectangle object from ToxicGeometry. There we go. I can create a rectangle that is exactly the dimensions of the canvas, and I can make that the world bounds of the physics world. And sure enough, the particle stops when it gets to the bottom. Let's add a second particle. Okay, so now I created two verlet particles, added them both to the world, and I'm drawing both of them. It's time to return to this diagram and look at how I would add a spring to connect these two particles. Now, when I created a particle, I only needed two arguments, an x and a y, for the coordinate of the particle on the canvas. A spring needs four arguments. The two particles that are going to be connected, let's call them A and B, then the rest length of that spring. What is the length that it wants to be? Call that length. And then the strength of that spring. This is a number between 0 and 1, where 1 would be very rigid, as if there's a metal rod between those two particles, and all the way down to 0, very elastic, as if it's just the particles are going to melt away and not be able to hold together. I'll make a new variable called spring. And spring is a new verlet spring 2D that connects particle A and particle B, maybe a rest length of 100 pixels, and let's try a strength of 0.5. What did I forget? I also have to add the spring to the physics world. And there we go. Did you see that lovely little bounce? Boing! It's kind of amazing that it just stays perfectly upright. I assume if I move maybe the particle over a little bit, it's going to fall over. Now remember, there's no geometry here. The spring is just a force that's acting between those two particles, but I could draw a line to help me visualize what's going on. Let's add a third particle. And let's connect particle B to particle C. Whoa, what just happened there? It's really hard to understand what's going on without all of the elements being drawn, which is something you could use to your advantage depending on what application you want to make. But let's draw that other line. Aha! Okay, next I want to show you how I can make this interactive. So something that you can do with a particle is you can lock it into place. For example, if I were to say particle A, lock, now everything is going to swing from particle A, and in fact I have a nice little double pendulum simulation already going. But once I've locked a particle, I can also manipulate its XY position without it participating in the physics. And then unlock it. So now as I move the mouse around, I can kind of swing this lovely little double pendulum all over the place. Let's have that only happen if I'm holding down the mouse. The logical next step would be, I've got A connected to B, B connected to C. Let's connect A to C. And there we go. I've got a nice little squishy triangle now that I can toss around and enjoy. Now, if you look at this code, it's a lot of repetitive stuff. I mean, I'm numbering things, A, B, C, 1, 2, 3. I could definitely use an array. I've got to say add particle for everything. I've got to draw all the circles and lines separately. There has got to be a better way. So what I want to do is completely reorganize this code in a way that will allow me to expand it to create much more sophisticated soft body shapes. Let's take a minute to think about what it is that I want to do here. I currently have a shape that has 3 points, all connected with springs. But maybe what I really want is to make some kind of blobby, cute character. And it squishes and squashes and moves around the canvas. I've got to think about, where are all the particles? How many do I have? And if they're all connected with springs, this could be a good starting point, but the whole thing is probably just going to collapse onto itself. So what if I built some sort of shape, but added some additional springs just kind of across the middle? Maybe I don't draw those to hold the thing together. So in order to be able to build something like this, I need to first reorganize my code so I can manage all the particles and springs in arrays. And then I need to think about the design of the skeletal structure of this particular character, and then how I'm going to layer a drawing on top of it. So number one, every time I make a particle, I'm using the ToxicLibs Verlet Particle 2D. But I want to have my own particle. I maybe want to keep track of things like its size. Maybe I want a function that draws it. I want to have my own particle class. So I can create a particle.js file, add a reference to it in index.html, and then go about writing my own class. So this is boilerplate code of a base particle class. It's got an X, a Y, and R for radius. All of those are initialized in the constructor, and a show function to draw it as a circle. But I also want this particle to have everything that a Verlet Particle 2D has. Now, if you happen to watch some of my other physics library tutorials, I would often do something like this. In this case, I have as part of the data of the object a reference to another kind of object. So it's essentially a wrapper class. My particle class is wrapping the idea of a Verlet particle. And in this case, I could probably get rid of the X and the Y. And then in here, I'd have to say, draw the circle at this.particle.x, this.particle.y. But there is another way. This makes sense in some scenarios. But here, I can use the power of inheritance. This is something that I cover in chapter 4 of the Nature of Code, and you can go back and watch the particle system videos where I look at inheritance and something called polymorphism in more detail. But for right now, all you need to know is that if I use the keyword extends and say that my particle extends Verlet Particle 2D, then suddenly it's as if I copy-pasted everything that's part of Verlet Particle 2D into my particle class. Only I don't have to copy-paste it. It's invisible. It's inherited all of it. And in fact, this is all the code I need except for one more change. It's not up to me to initialize the X and Y properties of that particle. I want ToxicLibs to do that for me. So I can reference the parent class, Verlet Particle 2D, with the keyword super. The parent-child relationship is often called the superclass to subclass relationship. So now I have my own particle class, which is exactly a Verlet Particle 2D, but I've added a radius and a show function. And I could go back into Sketch and replace all these. Code still works. Now look at this. Every particle I'm making, I'm adding to the physics world. And that's really going to be the case 99 times out of 100. If I'm making particles, I want them to experience the physics. I'm not making them just to leave them out. So a nice feature that I could add to my particle class is for it to be responsible for adding the particles to the physics world. So when I create a particle, the constructor is called, and right there in the constructor, I can say physics.addParticle. Now, what is it that I'm adding? I'm not adding a specific particle, I'm adding this particle. Inside the class, the way you reference any generic particle is with the keyword this. This particle's X, this particle's Y, this particle. Now, I could also replace the calls to circle in draw with the show function. Great, we're still cooking here. Let's give the springs the same treatment I gave to the particles. Here's the spring class, which extends Verlet spring 2D, calls the super constructor, adds itself to the physics world, and then draws a line. Now, you could make the case that I've done a no-no here in that I'm referencing a global variable, the physics world inside of the class. Maybe that should be passed into the constructor, but I just want to keep things simple for myself. In this case, I have one physics world for this whole project, and I'm just okay with referencing it as a global variable here in the class, even though that's not necessarily the best object-oriented programming practice. Now back in Sketch, I can change these to my own springs. And I can call the spring show functions. And we've got exactly the same functionality working, but I am now using my own particle and spring classes, which is going to open up a lot more possibilities in terms of how I design and visualize them, how they behave, what other properties they have, and so on and so forth. All right. Next up, let's change 3 separate particles and 3 separate springs into arrays. There we go. I am now putting the particles and the springs into arrays. I'm still individually making them. You might have your own ideas for how you might automate that process, but I want to design this character by hand. But the really nice thing here is I can iterate over the arrays to draw all the particles and draw all the springs. Let's take out the gravity from the world right now. And let's make the springs a little bit softer. All right, what could be a simpler version of this? I have a triangle. What if I did the following? What if I designed my character to be something like this? Let's start with that. Let me number how I'm going to put them in the array. And then I need to think about which spring connections I'm going to need and what the lengths of those springs are. So first thing is, if I turn off the physics, I can see actually where the particles are being drawn originally. Let me try to make up some points that I think might work. All right, there's all my particles and there's all my springs. Let's think about what I need the lengths to be. So the particles 0 and 1, so I totally drew it in P5 differently than it's here, but 0 and 1 and 3 and 4 need longer springs so it can maintain that shape. So let's give those 150. And let's see what happens if I just let the physics go now. Ooh, boy. So you can see that there is no structure being kept. So I've got to start thinking about what are some other springs that I might add internally to keep the structure maintaining its shape. How about a spring that connects 5 and 2? Maybe that's a little bit better. What if I connect 0 and 3 and 1 and 4? A little bit better. Here's the thing though, I'm making up these lengths of the spring. Maybe what I should actually do is have the rest length of the spring b, the actual distance of the particles as they are initially placed. In that case, I can actually get rid of this fourth argument completely. And then in the spring class itself, the length is the distance between A and B. Look at that. So now the physics is active, but it's not doing anything because I have created it with all of the springs already at their rest length. Which is particle 0? This one? So now we can see how this one is maintaining its shape pretty well. So this is what is known as debug view, in the sense that I am drawing all the particles and all of the springs. But ultimately, I want this to feel like it's a character. I don't need to see all of the dots and all of the lines. So let's actually comment out the show functions. Let's say begin shape, end shape, and let me create a closed filled shape out of all of those vertex points. Let's run this and see what happens. Look at that. Instead of drawing the particles and the springs separately, I just drew one shape with a fill. And look, there's my little soft body character. I hope that what I've given you here is the foundation to build your own character. I think an interesting question is, what if I wanted to add little eyes? Could I use two particles and another spring connection to make antennae or legs or other kinds of appendages that are flopping around? Maybe. 3 days later. All right, thanks so much for watching today's coding challenge. I have taken some time to clean up my code. I added some eyes and a little antenna to make the soft body character more fun. And I really want to see, what can you do? What can you build upon that I've done so far in this video to make your own character? Think about adding more points, more springs. Maybe you want to make a dancing skeleton or a squishy soft body letter form. So many possibilities. You also might want to take a look at other kinds of springs that are part of the ToxicLibs library. In addition to the plain Verlet spring 2D that I used, there's a Verlet constrained spring 2D, which is a spring whose maximum distance can be limited. And then there is also the Verlet min distance spring 2D, which is a spring that only enforces its rest length if the current distance is less than that rest length. So both of those might allow you to increase the stability of your system or constrain it within certain ways. Now, at the beginning of this video, you might remember that I said that I would follow up about the Nature of Code book. If you're not familiar with that project, natureofcode.com has the original book that I published in 2012. You can even buy a print version of this book online, but I would suggest you don't. Stop, wait, because I am almost through a complete rewrite with many new examples, P5.js code. I have stopped promising what date I'm going to finish that by because that date that I thought I would has passed so many times. But I have finally made real significant progress with this new version of the book. I'll link to the website where you can read the work in progress version. There's a GitHub repository which has all of the material for the book, as well as the code for how the website is built and the new PDF will be generated. So I don't have a mailing list or anything. I guess I do have this YouTube channel. There's social media. If you're following me, if you're subscribed, if you have your notifications on, you can be sure that when the book is finished, you will hear about it. And in fact, I just went through editing chapter 7, which is all about cellular automata, a word that I absolutely cannot pronounce. And I'm going to do the next coding challenge all about the Wolfram one-dimensional, the elementary Wolfram CA, the sort of CA that of all CAs. Thanks for watching. I'll see you next time.